Is complexity an illusion? Simplicity is held by many to be the key to general intelligence. Simpler models tend to generalize, identifying the cause or generator of data with greater sample efficiency. What this means is a simpler answer is more likely to hold true. The simpler a model gets, the closer it usually is to the truth. This is Occam's razor, the idea that simpler explanations are more likely. The implications of the correlation between simplicity and truth extend far beyond computer science, addressing questions of physics and even biology. Yet simplicity is a property of form, while generalization is of function. Any correlation between the two is a matter of interpretation. For example, I can choose how to interpret words, so can you. A simple sentence might mean a lot to me and nothing to you. This is as true of math and programming as it is of the English language. In theory, there could be no correlation between the simplicity of a hypothesis and how likely it is to be true, and yet in practice, there is. Previous theoretical research showed generalization to be a consequence of weak constraints implied by function, not form, and experiments demonstrated that choosing weak constraints over simple forms yielded a 500% improvement in generalization rate, in accuracy. In this paper, I showed that all constraints can take equally simple forms, regardless of weakness. In other words, once we take interpretation out of the picture, there is no such thing as complexity. However, if forms are spatially extended, then function is represented using a finite subset of forms. Intuitively, this means that words take up space on a page, and, likewise, matter in our universe takes up space. Two things cannot occupy the same space, and the information we cram into a bounded system is finite. This means function is encoded using a finite subset of forms, which means we can force a correlation between simplicity and generalization by making weak constraints take simple forms. We can force simpler things to be true more often. So why would this happen? Why is this the world we live in? Well, if function is determined by a goal-directed process that favors versatility, then efficiency demands weak constraints take simple forms. We can see this in our own designs, but it is also true of natural selection. Natural selection demands versatility within a narrow context. It demands weak constraints take simple forms. This means that complexity has nothing to do with generalization, but we think it does because we observe weaker things tending to hold true more often. This explains why complexity-based induction systems do sort of work. It shows why Occam's razor is a good rule of thumb to understand the world. And it also shows what we need to do to surpass it, to achieve superintelligence, and it has implications for things like consciousness. Philosophers speak of selfless consciousness, of a contentless void where concepts like trees and mountains dissolve into nothing. And if complexity is a matter of interpretation, and interpretation follows natural selection, then this explains how and why we might divide our world up into the distinct objects that we do, instead of always experiencing a contentless void, that is.